In the previous video, we exported the URDF file from Fusion. Now it's time to understand what is URDF and how we are going to use it for the further simulation. Okay, so let's get started with today's video. First of all, open the location where we exported our URDF folder. So we have opened the particular folder, Square Robot Mini Description, and then go inside the URDF folder and you will get the Square Robot _ min _ Zacro extension file. This is our URDF file and you have to open it with VS Code. Okay, so that's how you are going to open the URDF file. So first of all, going with the part, we are using Windows for now just to see the URDF file, but after this particular video we will switch to the Ubuntu. Okay, we are going to use only Ubuntu for ROS2, not the Windows system. Okay, that's for sure. Okay, now let's get started with the URDF. Okay, so URDF stands for Universal Robot Description Format. What is this particular format? Let's understand about it. So in the Fusion software, we added the links, we added the joints. Okay, for any robotic systems, the links, the joints are very important. Okay, because based upon that our robot is going to move, right? So whether it is about kinematics, the joints are responsible, the links are responsible, likewise. So in the URDF file, what we have is that the position of the joints. Okay, let's say here is our base link. Okay, so after this particular base link, we have added the inertial properties. Okay, from the plugin itself, we have not calculated these values. Of course, if we calculate these values, it will take hell lot of time. So that's why we are using the plugin to simplify the process, and that's completely fair. So we have the inertial properties, we have the mass value. Okay, what's the mass? Then we have the visual properties through which the components that we see are seen. That's the only meaning of the visual properties. And the important point is that the STL file is added here. Okay, so the STL file is added in the visual properties and the geometry. Okay, because both are related to the dimensions. Okay, what we see is about visual properties, so that's why the STL file is important, and then we have the collisional properties for that. So whenever the robot collides, the collisional properties are responsible for that, else the collision will not occur, the robot will simply pass throughout the wall. Okay, so that's the role of collisional properties. And similarly, each and every link has these properties. Okay, so we just studied about the base link, then the LiDAR link, then the camera link. All the other properties will remain the same with respect to the component. Okay, if the position of the camera is different, of course its moment of inertia and the mass is going to be different as per the size and all those things. Then we have the caster wheel, then the right wheel, then the left wheel. Okay, these are the properties. Okay, now the second part of the URDF is about joints. Okay, so joints are the very important and the crucial part, because unless and until you don't consider a joint in a robot, how it is going to move, right? So for the joint, the joints which are only responsible for the motion are important, but also which are not in the motion should be fixed, or else the robot will not move together. Okay, it will move in different parts. Okay, so that should not happen. So here we have LiDAR sensor where we have fixed it, then the camera joint, it is also fixed, then the caster, it is fixed. And while fixing, just check out the parent link and the child link. Okay, so the parent link here is base link, right? Then we have LiDAR, because the LiDAR sensor is connected to the base link. So base link here is parent joint and the LiDAR is the child link, which depends upon the base link. Similarly, the case is for the wheels. The joint is right wheel joint, which is a continuous joint, because whenever the wheel moves, the rotation should be continuous. Okay, there is not only specific rotation like 30 degree, 60 degree like a servo motor. We are using a DC motor, so the rotation should be continuous in order to move the robot further. And then the parent link is base link, the child link is right wheel. Okay, and here we have axis for the rotation. So whenever the wheel rotates, it rotates with the help of a particular axis. So that is important to be considered, and based on the axis, whether it moves clockwise, anti-clockwise, it depends on the axis. So that's how it goes. And then we have the left wheel as well. So in the like similar to the right wheel, the left wheel will also rotate. So yeah, this was for the URDF in this particular video, and in the next video we will take this particular folder, the package, the complete package, into the Ubuntu environment. Okay, you can take the package that we just exported from the Fusion through your WhatsApp, log in your WhatsApp to the Ubuntu environment, zip this particular package and take there, share with yourself on WhatsApp, download on the Ubuntu. It's one way to go with this procedure. The other method is just simply take your pen drive, just add the zip file into that pen drive, and then you can just export the file from the pen drive in your Ubuntu system. So that's how you can do, but getting the package into your Ubuntu environment is important, right? So we will meet in the next video. Till then, grow, learn and explore together. Bye.